Hey guys, this is Mr. Wolf, and I'm going to be going over Target 4 for Unit 2. If you guys could open up your packets to page 8. So what we're going to be doing for Target 4 is really looking at your ability to analyze changing motion, this time through equations. So last time we did velocity equals distance over time. Now we're going to be introducing some new equations now that we're working with changing motion, now that we're working with this acceleration. So the main terms to know again are going to be acceleration and also this time instantaneous velocity. Right. So just a little bit again of a review on acceleration is that rate at which velocity is changing. Our units are going to be meters per second squared. You're going to see them like this often. However, I always like writing it in terms of meters per second every second. This really just shows that this is indeed, acceleration is indeed a rate. So acceleration requires direction. So it's going to be a vector. Important to remember. So you could be going in the positive or negative direction, up or down, left to right, north, south, east, or west. Now, so you'll see at the bottom of page 8, there's two equations, but I'm going to go through, where do these equations come from? And so I'm going to review of what we did from Unit 1, when we looked at that distance versus time graph with that constant motion cart, and we got a line like this. So what we did is we made a y equals mx plus b equation. We found that our distance this time was substituted for y, and time was substituted for x. Now b is something here, it's that starting position, but now we're just, since it's 0, we're going to ignore it. So now we had to find our slope, and so we took our units of meters in seconds, and it's going to be meters per second. That was equal to our velocity. So our equation was distance equals velocity times time. So we're going to do something very similar with this next graph, except now we're going to be looking at a velocity and time graph. So this is going to be, when we did that bowling ball experiment, our distance versus time graph, we had that curve that went up like that. And so if we were to make this a velocity time graph, our velocity would be increasing at a constant rate. So what's going on here? Well, let's do that y equals mx plus b equation again. So y here is now velocity, and x is time. And b is 0 here, but this is actually going to be our starting velocity. We could start at 0, but we could also start at about 5 meters per second and increase our velocity from there. So what I'm going to do is I'm going to put velocity and then this little subscript 0 here. That is our initial velocity. All right, so now all we need to do is just solve for that slope. And so let's look at the units. We have meters per second and seconds. So when we do our rate, it's going to be meters per second. So this is the exact same thing as acceleration here. So now our equation is going to be looking at v equals at, or acceleration times time, plus our initial velocity. So if you look at the bottom of page 8, that is your equation. So all we have to do to get that other equation at the top is just kind of rearrange some variables. And so we're going to do that on the next page. All right, so here's that equation that we just came up with. If you take a by itself, you'd get this equation right here. And then basically this final velocity minus the initial velocity is going to be that same thing as your change in velocity. So really all these equations are the same thing, they're just rearranged in a different way. However, you're going to be using them sometimes for different circumstances. So for instance, if we ever want to find our instantaneous velocity, this is going to be the equation that we're going to want to go with most of the time. So let's apply this to a problem now. So you guys go to page 9 of your packet, check for understanding 15. A car takes 4 seconds to come to a stop, assuming our acceleration is negative 7.8 meters per second squared. What was the car's velocity just before the brakes are applied? So let's first just look at our givens. We have our time is 4 seconds, and our acceleration is negative 7.8 meters per second squared. And it's important to recognize that our acceleration has direction, and in this case, it's going in that negative direction. So now we also have our final velocity, because it says that our car comes to a stop, and if it's at a stop, we know that it's going at 0 meters per second. So it's asking is what was the car's velocity just before the brakes were applied. And so that's actually going to be our initial velocity. That's what we're looking for. That is our unknown. So what's that equation that has all these variables right here? Well, we just derived it from that graph, and that's going to be our velocity is equal to acceleration times time plus our initial velocity. So now let's just plug in our variables. And so our final velocity is 0 meters per second times our acceleration. Remember, we want to make sure that we're keeping it negative here. Multiplied by the time, and then plus our initial velocity. So what we're going to get is 0 equals, and we multiply these together, negative 31.2 plus v naught. So all we have to do is just get v naught by itself, and so is equal to positive 31.2. Now we also, we want to end our equation with units. It's asking for that initial velocity, so velocity is going to be in meters per second. And just to kind of go over the idea that this acceleration is negative. Basically what it's saying here is when our acceleration is negative is that this is going to be decreasing our velocity. So if you think about it, this car started off at 31.2 meters per second and decreased its velocity to 0 meters per second. We have a negative acceleration then. All right, so for homework, just to give these problems a shot is just check for understanding number 16 on page 9, and then try the plug and chug practice. Don't do every problem. If you could, just do number 1 and number 4. Number 4 is going to be a new equation we haven't seen yet, but it's just good to be introduced to it. Alright, and so that equation is going to be v squared is equal to initial velocity squared plus 2 times acceleration times the change in distance. And that's going to be for number 4. Try it out. Again, if you guys are struggling with these problems, that's fine. Just say, I'm not sure because, and then just kind of give you the reason for your struggle. I just really want you guys to just work on these. We'll go over them in class tomorrow. So good luck, guys. I'll see you guys tomorrow.